Hi everyone, it's Miss Moon coming to you from the top of my water bottle so you can watch what I do as we discuss and do some practice problems for Charles' Law today. Now Charles' Law relates volume and temperature to each other, and last week we looked at a demo experiment with balloons in a hot water bath and balloons in a cold water bath. There's a video showing this phenomenon on our Google Classroom slideshow for this unit. It should be right after, I think it's right after the demo explanation on the slideshow. So you can check that out, and as you look at it, you should be able to answer the following questions. Number 1 says, what happens to the volume of the balloon in the cold water? If you watch the video, I think they might put the balloon in a freezer instead, and that balloon should get small or smaller. So I'm going to say that volume decreases. It gets cold, the volume goes down. When it gets hot, it does the opposite. Volume increases. Now we need to explain why this happens, kind of thinking about it at the molecular level. Well, when temperature increases, the kinetic energy of the molecules of gas also increases. So they're moving a lot faster. And when they move faster, they're going to have more frequent collisions with the inner walls of the balloon. In addition, those collisions are going to have more force because they're already moving faster. So, when those two things occur, increased collisions and more forceful collisions, the balloon's going to be forced to expand. As that balloon expands, we're going to see that their relationship between volume and temperature looks like it's direct. Volume increases as temperature increases. Volume will decrease if temperature decreases. So the variables do the same thing as each other. For number 3, I'll explain it like, as temp increases, collisions become more frequent and have more force with the inner walls of container, causing container to expand. Now the key for looking at Charles' Law is we need a flexible container, so a balloon works really nicely to show us this relationship. As we talked about a little bit earlier, this is a direct relationship. If one variable increases, the other variable increases, and vice versa. Now, let's get into the math. I've already written at the top of this sheet the different equations we're going to be using. So anytime you're solving for volume, it's going to look like this. Anytime you're solving for temperature, it'll look like this. We've rearranged this initial relationship to be a little bit easier to use for our algebra's sake. Now this one also involves temperature, so don't forget, anytime you're given something in Celsius, you need to convert it into Kelvin by adding 273.15. Let's do 2 together, 1 finding volume, 1 finding temperature. I'm going to start with 2. This one says, a balloon was inflated to a volume of 2 liters at a temperature of 7 degrees Celsius. It landed in an oven and was heated to 147 degrees Celsius. What is the final volume of the balloon in liters? All right, looking for final volume, so I'm going to be using my V2 equation. Now I need to figure out who's who. Starting with V1, my initial volume is 2. It looks like the initial temperature was 7, T1, And the final temperature when it was in the oven, T2. Now our temperatures here are in Celsius, so we need to convert them to Kelvin in order to use this gas law. To do that, for T1, we'll take 7 plus 273.15, and for T2, we'll take 147 plus 273.15. So this should be 7, 8, 9, 10, 280.15 Kelvin. This one, a little trickier. I'm going to pull out my calculator. 147 plus 273.15 is 420.15. All right. Now that we have all of our variables in the correct units, we're ready to plug into our V2 formula, that rearranged formula. V1 is 2 times T2, which is 420.15. And this is all over T1, 280.15. Since temperature is increasing, we should definitely see a volume increase here. So if our final answer is greater than 2 liters, we did it right. So N over D button, 2.0 times 420.15 all over 280.15, and I got 2.99. This was rounded to 1 decimal place. If I round this to 1 decimal place, we should get 3. V2 equals 3. Since this is a volume, and we were given our initial volume in liters, our final volume should be in liters as well. Let's do one more. Might as well just go right across, do number 5. This time finding final temperature. A balloon filled with 0.8 liters of air has an initial temperature of 22 degrees Celsius. What is the final temperature of the balloon in Kelvin if the volume increases to 2 liters? Okay, first, I'm using my final temp equation, T2. Second, let's figure out who's who. A balloon filled with 0.8 liters, this is our initial volume, V1, has an initial temp, T1 of 22. The volume increases to 2 liters, that has to be V2. Let's go ahead and plug everything in. We're taking T1, 22, except it's in Celsius. We have to change that into Kelvin. So 22 plus 273.15 is 295.15. Okay, now we can plug it in. Our T1 is 295.15 times our V2 is 2 liters, all over our V1, 0.8. Let's see what we get. N over D button, 295.15 times 2 all over 0.8, 737.875. Oh, that's crazy. Now, our volume increased, so we should see an increase in temperature, which we did. I'm feeling like I did my math right. Let's write down our final answer, 737.86. I'll round it to 2 decimal places since this has 2 decimal places. Actually, 88. I was looking at the 5. We want to increase that 7 to an 8. So 737.88 Kelvin. Sorry, that 8's kind of ugly. All right. That is Charles' law and some of the math that goes along with that, whether we're solving for final volume or final temperature. All these equations are on the board for you as well. Make sure you get them down. We're using those as you try to finish the last 4 problems. Once you're done with that, you can check the answers. The answer key will be under the projector. And if there's anything you haven't finished from yesterday's practice, you can work on that too. Tomorrow, we'll jump into Boyle's Law.